You now know that variables are the basic data objects manipulated in a C program. I now want to talk about the movers and shakers of those variables. I'm talking about operators and expressions. Operators specify how your variables are manipulated. Expressions combine variables to produce new values. C supports the typical binary operators you're all familiar with: addition, subtraction, multiplication, and division. C adds additional unary operators as well. Let's take a closer look at operators and expressions in C. Operators and expressions are fundamental to programming. Let's take a look at their use in C. The first thing we'll do is go to our development folder and create a new subfolder and call it Operators and Expressions. Copy our template for our C program and place it in the folder. Now open the project in Xcode. Now let's remove the print statement that's there, leaving the return 0. So let's declare an int variable called a and initialize it to 9. Let's print 9, something we've become familiar with at this point. Nothing particularly special. But there is an error. We did not actually include the variable that we wanted to print. Actually, let's take a look at this. We see unused variable a, and our print statement is pretty much gobbledygook. Insert the variable a, our warnings disappear, and a appears. We'll now look at something called auto-incrementing. We'll declare a new variable c and assign it a, and then auto-increment a after the assignment. The pluses translate into a plus 1. Placing the pluses behind the a makes this statement mean assign a to c and afterwards increment a by 1. Let's now print both c and a. So if we've done things correctly, C should have the original value of a, which was 9, and a should now be 1 plus 9, or 10. C is now 9, the original value of a. A is now 9 plus 1, which is 10. Let's declare another variable, d. Let's auto-decrement a and assign a to d. Auto-decrementing is subtracting 1 from a, which would make a, which is currently 10, make it 9 again. However, in this assignment statement, it translates into d is equal to a minus 1. We have decremented a before the assignment to d, as opposed to incrementing a after the assignment to c. Let's print those values. To speed things up, I'll just copy and paste the print statement we used for c and a. Let's run this. So d is now 9, which is the previous value of a minus 1, and a has now been decremented back to 9. Let's take a look if we, instead of auto-decrementing before the assignment, we auto-decremented after the assignment. D is assigned the original value of a, which was 10, but a is still reduced by 1 back to 9. Let's take a look at an operator called modulo. We'll declare a new variable b and call it a modulo 4. I know you're thinking, modulo? What's a modulo? Recall your long division from school. Remember learning about remainders? The modulo operator returns the remainder after division of one number by another. So let's print out what we have. So a is currently 9. 9 divided by 4 goes in 2, leaving 1. That is the remainder. The remainder is assigned to b. And the value of a remains unchanged at 9. C, of course, has all the typical binary operators we've become familiar with. For example, I can declare a float variable, fa, and assign it the value of 5 divided by 0.5. So 5 divided by 0.5, or 5 divided by 1/2, is 10. C also provides a compact version of addition, subtraction, multiplication, and division. And here we'll use the compact form of multiplication. So FA times equal 10. What this means is take the original value of FA, multiply it by 10, and assign it back to FA, all in one line of code. This is a shortcut for the long way, which would be FA equals FA times 10. So we could have written FA equals FA times 10, but we're replacing all of this with a single binary operator, FA times equals 10. Let's see what the value of FA is now. The value is 10 times 10, or 100. This compact form can be used by all the binary operators: multiplication, division, addition, and subtraction.